This is Carla Columna, live from the last stage of Tour de Alps. We are slowly approaching the halfway point. The two favorites, Glens and Peter, are evenly matched. With a slight headwind, no one dares to break away yet. We are excited to see how the race continues. And now it is happening, dear audience, I told you, Pete tries to break away and attack. Pete's attack was successful and he is now ahead of Glens by a few curves and... wait! What is happening there?
Shit! What the heck is going on? My bike? No! Sabotage! Unbelievable! My bike cannot just fail out of nowhere. Somebody has manipulated it. I will report that to the race committee. They must investigate that case.
After the unexpected failure of Pete's bike, Glens wins the race by a large margin. Pete senses cheating and the fans agree. The race organizers decided to entrust the famous Shearlock Hopes from the ICAMS Institute Bochum with the investigation. Only he can solve the case. Is it really a sabotage or why did the material fail?
This must be the parcel from France. We have to go to the lab to investigate the microstructure around the crack. That will tell us the truth.
Hey, and welcome to ZGH. My name is Jan, and I'm a PhD student in Shearlock's group. As he explained, we need to take a closer look at the microstructure of the fork to understand why it fractured. For this, we are working together with our colleagues at ZGH. We will use their scanning electron microscope to get a very detailed image of the microstructure. The first step was to prepare a sample. I've already done that, and now we put the sample into the chamber of the microscope. Look at this. Here we can see two pores. The crack started here, and then it slowly grew through the cross-section. At some point, the cross-section was so small that the fork couldn't transmit the forces anymore, and it fractured, as you can see by this final fracture zone here at the outside. It seems like the pores were responsible for the fracture of the material. Maybe the designers were not just aware of these big defects. My colleagues will now do a numerical analysis to see how the pore influenced the mechanical behavior of the material. For that, we need to make another special image, where we also use the SEM device for.
Hello, my name is Ruhr and I'm a PhD student as well. The special image that Jan prepared for us is an EVST scan. I enlarge it here for you to have a look. On this colorful image, we can identify different grains of the macrostructure. Each grain is colored according to its orientation. We can see how large the grains are and how they are shaped. We can also see the grain boundaries. The EVC scan provides us with all the relevant information about the macrostructure. Then we can use this information to construct the macrostructure in computer. For this, we use the Python software Canopy developed in our institute. We feed in the information from the EVST scan and Canopy then approximates the distribution of the grain shape, size, and orientation and produces a digital twin of the microstructure. The 3D reconstructed microstructure is statistically equivalent to the real microstructure, so we call it a representative volume element or RVE.
Hello, I'm Feng. I'm also a PhD student here. Now, I will use RVE to simulate the situation during the race just before the accident. I've loaded RVE from the Canopy into the simulation software. Now, you can imagine it as a small section of the bike's fork. Here we can see the pole. Now, we are applying the forces that occur during the race. Due to the vibrations, tensile and compressive loads alternate with high frequency. We have only simulated a small section of this cycle here, but the crucial problem is already visible. Now let's see what happened. Here we can see local stress concentrations occurs at the edge of the pole, as shown by the red color. the stress close to the pole is much greater than in the solid material away from it. A fatigue crack forms and then continues to grow because of the oscillating load. Here we can see how many load cycles the material can endure at which stress level. As the figure shows, the lifetime reduces drastically when the stress gets higher. At the pole as large as this, doubles the stress level around it, which reduces the lifetime by a factor of 1000 for this material. Instead of lasting for 1 million cycles, this block already broken after about 1000, only in the second race in this season.
Shit!
The combination of experimental investigations and materials modeling across the scales, my team could solve the riddle about the broken fork. And we could demonstrate that it was broken by natural metal fatigue and not by sabotage. So this shows us that science can help us to find the truth in such cases. And if you want to become future Shearlock Hopes and solve such riddles, join us at ICAMS.